So, for example 1 here, we've got a point on the terminal arm of an angle in standard position. Now our point is at -2, -4. So the first thing we're going to do is we're going to draw that point. It's going to be in quadrant 3. And you're going to find that the way that I do these questions are going to be slightly different than the way the pretest does them. They're going to be slightly different than the way the example is done beside in your textbook. So the reason I do them differently is I think this is the easiest way to learn it. Okay? You guys are good at triangles. You're good at sine, cosine, tan from grade 10. So we're going to use that, and you don't have to memorize any additional definitions that I think in the end are going to confuse you. So here, we've got a point -2, -4. We know that that's on the terminal arm of some angle in standard position. This is the angle in standard position. It would start here and end there. Now, what happens is once we have that point, we can make a right-angled triangle. If we go back to the nearest x-axis, and the reason we go back to the nearest x-axis is that's how we do things with our reference angle, then I can make a triangle like that with my nearest x-axis. It'll always be a right-angled triangle. This angle in here will be our reference angle. As far as labeling reference angles, they're often labeled with the same. If this angle, this red angle is theta, we would label our reference angle with a little r beside it. So that's how we can label a reference angle. So now that we've drawn a triangle, what do we know about this triangle? How long is this side? 2. How long is this side? 4. If you wanted to find the hypotenuse, could you? A squared plus b squared equals c squared. 2 squared plus 4 squared is the square root of 20. And the square root of 20 isn't simplified. It's the same as 2 root 5. So now we know all 3 sides of this triangle. And part A becomes really easy. To find sine, cos, and tan of theta, we just have to think of our reference angle. Because what we learned before, well, I'll go all the way back up. Where was it? Here. Right? When we did this before, with 35 degrees, we found out that no matter what quadrant something's in, if the reference angle's the same, sine, cos, and tan are the same. So we can do sine, cos, and tan of this triangle that we've made, and then just apply it to our cast rule to figure out if it's going to be positive or negative. So let's go. We're going to figure out sine of theta, cos of theta, and tan of theta. Now on your triangle, here's our reference angle. So that's the angle that we use. Which is the opposite side of this reference angle? It would be the 4. So since sine is opposite over hypotenuse, we're going to get 4 over 2 root 5. And of course, you're going to have to rationalize. So you're going to have to multiply both top and bottom by root 5. And you would get 4 root 5 all over 2 times 5 is 10. And that 4 over 10 can simplify to 2 root 5 over 5. Cos of theta. What's the ratio for cos of theta? It's the adjacent side over the hypotenuse. And if you rationalize the denominator by multiplying by root 5 and root 5, you're going to get 2 root 5. 2 times 5 is 10, which simplifies to root 5 over 5. And finally, tan. Tan is the opposite over the adjacent. So I just simplified things here, but now we're in quadrant 3. In quadrant 3, which is the one that's positive? So one of the things you're going to do is you're going to quickly write out your cast rule and check. In quadrant 3, there's a t. what does that t mean? Tan. And what does that mean about tan? Only tan is positive. So when we go here, when we've got our final answers, for sine, we're going to have to add a negative. For cos, we're going to have to add a negative sign. Tan is going to be fine to stay at positive 2. So the ratios are negative 2 root 5 over 5, negative root 5 over 5, and 2. You'll notice at the bottom of the page, they didn't rationalize the denominators. You'll be expected to rationalize the denominators all the time from our radicals unit. Okay? What is the measure of angle theta? Again, we don't know what all of theta is, but looking at your green triangle, could you find this angle right here using grade 10 sine, cos, and tan? Yes. You could choose any one of them. You could choose sine, cos, or tan. Which one looks the nicest to work with? Tan, because it's a nice numbers, no square roots. So I would probably use that one. I would say tan of theta equals 2. So theta is going to equal tan inverse of 2. Go to my calculator. Tan inverse of 2 comes out to 63.4. It's to the nearest degree. So that's roughly 63 degrees. Now, if my reference angle is 63 degrees, and I need to put a little r there, because I was figuring out my reference angle, not my angle. Okay, that's why I labeled this one as a theta r. Now I'm going to go to my red one. How am I going to figure out what theta is going to equal? If I figured out this one right here, this reference angle was 63 degrees, then the whole angle will be, well, it's 180 up to here, and then 63 more. 243 degrees. So this question is sort of bringing everything together. If you draw a triangle, you can figure everything out from the math that you learned in grade 10. Sine, cos, and tan, a squared plus b squared equals c squared. We have to use a little bit of our radical unit to simplify things. Then once you've got everything, including finding the angle in that triangle, then you can use the idea, well, I know my reference angle, how can I find my entire angle? Okay, questions you can do are 6, 10, and 11.